Good afternoon, everyone. Hopefully, can you hear me okay? Yes? Very good. My name is Mick Hodgson. I'm Technical Manager for Tekla, Finland. Now, obviously, I'm English, not Finnish. And I'm from Manchester, England. The first thing people say when I say I'm from Manchester, England, they always say, Manchester United. But not today, obviously. My presentation today is going to be on about BIM in fabrication. People think that BIM is for engineers and architects. I'm going to talk today about BIM in the sort of fabrication process, the process of actually making the piece of steel in the factory. In our Tekla world, we get involved with many different types of projects, from general steel structures, offshore platforms, wind turbines, bridge work, transmission towers, every kind of constructional project. And as you've seen, what we're doing is, with Tekla Structures is a software, and what Tekla Structures is used for is for detailing those projects, prototyping the projects in 3D, and then creating all the information that's needed for manufacture. I hope my translator's keeping up with this. Now, I'll start with a few kind of glamorous examples, first of all. Our main sort of day-to-day work is shopping malls, sports centres, office blocks, that kind of thing. But we get involved in many sort of glamorous projects, such as the Brazil football stadiums. All the stadiums for the football, for the World Cup in Brazil were done on Tekla by our Brazilian clients. We get involved in highway projects, bridge work, sometimes architectural, sometimes regular highway bridge work. Looks simple, but it's complicated built-up plate work. We get involved in architectural style projects as well, such as the Sky Park in Singapore. And other architectural projects as well, such as the museum in Singapore as well. The beauty about three-dimensional software is it allows you to do really complicated 3D geometry without worrying about the mathematics. So as a detailer, all I'm doing is building that project in the computer, let the system worry about the mathematics, and it will create all the manufacturing data. So a nice glamorous example there. And to finish with something more simple, like some transmission towers in Italy. Okay, and a few other examples here taken through sculptures, offshore platforms, bridges, etc. So that's the kind of work that we at Tekla get involved with our software in the steel segment. I'll skip that. Now, as I said before, BIM is not just for architects and engineers. This BIM also goes all the way down to workshop floor production. So production of pieces in the workshop and the data fed back into the Tekla model. So the Tekla model all the way down from the engineer goes into the Tekla itself, then of course down to production, back to the Tekla model. You'll see that in more detail as I go through this. Okay, my example today is going to be not a steel fabricators, but actually steel stockholders. And it's quite a unique concept. So rather than being a steel fabricator, what they do is they're actually a warehouse. Somebody mentioned warehouses earlier, and this is how we can actually link down to the warehouses directly. There's a company in the UK that's recently opened called Parker Steel. It's a long-established company, but they've just actually opened a brand new facility costing 22 million euros. It's the first UK supplier where you can buy the steel online. So when you've done the Tekla model, you can click a button and you can actually get the steel delivered to your factory, either by length or pre-processed. So it's a quite unique concept. And there's a few of these facilities now happening around the world. This is the facility itself. It's brand new company, brand new building. That's a facility inside. It's almost like a Boeing 747 factory, actually. Beautiful, clean. Very few people work here. It's fully automated. Even the transfer of steel from one position to another is fully automated. So it's all driven from the actual Tekla models. You can see what happens here is it's actually built on the dock side. So the steel can be imported from different countries around the world. So it comes from Poland, it comes from Portugal. So the cheapest supplier can supply the steel into their stockyard, and then from there it's processed to the UK steelwork market. They don't just provide structural steelwork, they do all kinds of specialised operations like folding, laser cutting, water jet, tube cutting, shot blasting, all different kinds of general production processes. That's just a picture of their crane, which is for unloading. You can see then that's a stock that's been brought into the yard. There it is, ready to be processed. Again, this stock can come from anywhere around the world. So it's important that the steel is up to a certain specification, and a certain grade. So the traceability of that steel and where it finally ends up on site is very important in the steelwork market. We have to be able to trace back every piece of steel in a structure to where it was actually brought from or bought from. So the traceability, the certification of the steel is really important. Back to the warehouse. Okay, you can see the facility within there. As I said, it's fully automated. So here's their plant. Here's the guy just working the machine itself, but pretty much just one person running quite a large area of the facility. From the Tekla model, then, what they do is they can quite simply, once the model's completed, they can click on, for us in Tekla it's great, it's one click. We don't have to worry about detailing in a certain way or producing things. We just click a button, it creates the information to send out for the ordering of this steel. How that actually looks in real life, here you've got your sort of Tekla model. You've seen a few of these. This is just a small area of a bridge, complete with bolts, cuts, copes, openings. Then all we have to do here is click on the XML and say, okay, export out the whole model. That creates one file. Traditionally, when you export to CNC machines, it creates a file for every individual piece of steel. And on some projects, that can be hundreds of thousands of files. This creates one file, which then you send to the factory. If there are changes to the project, it sends a new file, it compares the two, and will tell you which one needs to be replaced or remade. So it's a full revision control system as well, so it's very easy. And for me as a detail, it's fabulous, because all I do is click a button. So we say, okay, start that, and it downloads that project then to take to the ordering system. What the guys see then, when they get actually in the factory itself, is they download the steel. They can see this is the elements that's come directly from Tekla. So you can see this is a project which I named Riga. It's all in phase one, and each one of these is a fabricated assembly. So it shows you all the plates that go together to make that assembly, and the main piece that those are fixed to. Uniquely, you'll notice that also it marks the steel to show how the pieces fit together. So this is quite new technology. So a drawing to put this steel together now is no longer required. This piece of steel itself becomes the drawing. So it's part of the BIM process is not so much paperwork needed, and this is the first step towards that. So now the actual fabricator gets this piece and he puts the elements together to make the actual welded assembly. Let's just go back here. Okay. So you can see then what he does is he exports the data from Tekla. Different formats you can go. We're actually using the IFC format here, which is the new format which you've heard about earlier. So it's not just for engineers, it's also for the fabrication facility. And then again, what you get down to the production site then is the individual pieces ready for production. These pieces then, you can see are already laid out, as explained earlier, to show how they fit together and what piece it fits to. So this piece fits on the end of this beam here and welded together. So a nice fit together. Kind of almost like an IKEA kind of wardrobe when you buy it and you have to put it together yourself. It's that kind of thing. Once it's there, then what you can do is you can then say, okay, calculate that, how it's nested into the bars. So how much steel do I actually need to buy to cut these pieces? So again, if we go back to the actual software, we can pick up that project. We can say, okay, let's process that. So say run that project. Then what it does with this project is it shows you how that should actually go through the factory. So for example, you've got piece here, which is a tube. You can see then what happens with this is it goes, first of all, it goes to the sew and drill line for sewing and cutting, and it's going to take 6 seconds to actually cut that piece of steel to length. And then from that, it goes to shot blasting, assembly, welding, and painting. So every piece, you can see how that goes through the factory. So this plate here, you can see it goes down to the Gemini plate cutting, and it's going to take 18 seconds to process that. So they can actually tell you by downloading the model exactly how long it's going to take them to make those pieces of steel. So it's an estimation of how long it's going to take to produce the actual steel building. Once that's there, we can then say take it to section nesting. This is for ordering of steel, so placing those now into one bar for cutting. It'll become more obvious when I've done it, so we'll just say automatically nest that. So my warehouse now will have certain lengths of steel. This finds the most optimized size and length to nest into, and then will give me the sort of purchasing orders. This is linked to the warehouse, so it's a direct link to the warehouse. So you can see that's the scrap at the end. You can see that's the actual saw blade cut. And that then is one length at 12 meters, cuts all these pieces. Like so. So you can see it cuts that piece, it cuts that piece, and it cuts that piece there. So that's the full automation of what you need to buy. So one click from Tekla allows you then to drop it down to the actual production machines, tells you how it goes through the factory, and then tells you what length of steel you need to buy. Simplifies great, one click, it's good stuff. Okay, then of course what's left over then are the plates. The plates need to be put onto sort of a plate nesting software. You tell it what size plate you've got, then it will work out the most optimum way to actually fit and with minimum wastage to fit those plates onto the sheet with minimum wastage. Again, let me show you this live. Just put a few of these down, so just exit that and that. So this is a plate nesting software. Now there are many different plate nesting softwares on the market. You can choose what you want. We can link down to these softwares. If I just quickly run this through, it's more easy to show than it is to explain actually. So this particular size and grade, what I've got then is I've actually got a steel sheet. It's loaded up. So this is a steel sheet I've got in my workshop, which is here. And these are all the plate parts from Tekla. So that's the size. I can tell it it's 6 meters by 4 meters. Then what we do is we say, okay, work out the most cost-effective, optimum way to nest that. And it looks at those pieces of steel and places them on the actual piece to be cut. Again, it takes a few seconds just to compute this through, because it's quite heavy kind of mathematics. So we'll just let that run through. It will get there eventually. There we go. And you can see that it's nested those pieces on there. And those are complete with the holes, the marking of the pieces, everything as well. So that now can go down to the machine in the workshop. The machine in the workshop, if I just take a look here, sorry for jumping around here, then looks like this. I'm not going to have this on too loud. So you can see that this machine has got all the operations, so all that automatic data, there's no manual program in here. The actual data directly from Tekla drives that machine and tells you exactly how to operate. I'll just skip it a little bit further on. There's many operations like screw threads, plasma cutting, that kind of thing. So you can see then it goes down for plasma cutting to the table. Okay, so again, that one click into the software drives the whole production facility. Okay, let me just close a few of these down here now. Okay, so that's the plate cutting. Of course, there are also specialized items like tube connections as well. I mean, we also have within Tekla a library of tube-to-tube connections. The new range of machines, normally, traditionally, you have to draw these old wraparound templates, sort of the unfolding of the pipe. What we do here is we place the connections within Tekla, and then it downloads directly to the machines as well. So this allows you to sort of drive the machine with its weld preparation at the same time to sort of directly from the Tekla model. So all these machines are driven directly for me. Again, let me just quickly show you that. You want to close that down. Here we go. So bin forum, and let's just go then to the HGG ones. Okay, and if I just show you, let's say this one. So the machine itself looks like this. So it's a specialized pipe cutting machine. And again, the data to drive this machine, that's what comes from Tekla. Then from this, it drives the machine directly as well. All the operations for the three-dimensional cutting, loading, everything straight from there. So any kind of specialized profile we can cater for in our software. You can see that's a speeded up sort of cut version there. But if you notice then the three-dimensional cut of the head, so it's doing the weld preparation at the same time. So one cut does every operation. Marvelous technology, actually. And you'll see when that fits together then, how clean it is. There's no sort of fixing. That's ready to sort of go straight into production. All of these links I'm showing you here are part of standard Tekla. So if you have any of these softwares, you can download directly to them. You don't need anything special. You don't need to buy anything other than the Tekla links themselves. Sorry, the Tekla links come with it. Okay, so you've got the pipe connections. You can see then that that's what it achieves, all different types and styles of pipe-to-pipe connections. And that's the sort of final process. Okay, so once it's then into the factory, they can then run it through. As I said, they will give time calculations for every piece and tell you how long it's going to take you to put that project or several projects through the actual factory. Then once it's done, they can then say, okay, if you want to buy just a raw piece of steel, it's going to cost you so much. If you would like to supply it drilled, it's going to cost so much. If you'd like it sawed, drilled and marked out, there's other cost implications. If you'd like it fully processed, for example here with all the copes, marking, drilling, everything, then it's going to cost a sort of premium. So you can choose how you want to buy that steel. Do you want to buy it raw and process it yourself? Or if you're over capacity, then this factory can actually make it for you and provide it already pre-made. Okay, then again, what it does then, it goes from the stock into production. As it's going through the production facility, it's actually tracked by iPad, like you saw on this one here, but specialized software for sort of warehouse tracking. And then it goes through the factory itself, so it's flowing through the factory. As it goes through every machine, the machine tells Tekla where it is in the workshop. So as it goes through a machine, it tells Tekla, okay, I've gone through this machine. Now I've gone to this machine. Now I've gone to painting. Now I've been delivered to site. So all this flow through the factory is fed back to my Tekla model. And what we see in the Tekla model then, as you saw from Sampo's example, so as it's actually feeding through there, I'm going to show you that live anyway. So as it feeds through, the actual building will colour code itself. That was supposed to be an animation, but decided it's not going to work. Okay, so in the Tekla model, you have it same kind of thing. So if I click on here, just like Sampo showed me, what we've got then is you've got sort of different attributes. So what's the CNC progress, where it is in welding, where it is in painting, where it is in shipping. So you can see the different dates. Those dates are automatically applied. So no Excel spreadsheets, no manual filling in. This is all when the machine goes through the machine, bang, it tells the actual Tekla model where it is. Then what we can do is we can color code it. So we can say, okay, what's the steel project's status in the workshop? So what we have is we have a ghost of that project. So nothing's gone to production at the moment. It's color coded. Shipping is red. Painting is blue. Welding is yellow. So we can say, okay, step forward a day at a time. You can see these pieces here. I've gone to the CNC machine. And as you step forward, you can see how that is progressing through the workshop. Red means it's been fully shipped to site, like so. So that's how we can tell the progress of that. And so that's actually automatically fed back to the model. So that progress is already there. Okay with me so far? Yeah? Thank you. Okay, and again, we've got touch screen. It all feeds back as well, the sort of iPad version. You can have color coding on the model as well, so you can get on the sort of Field 3D, the color coding as well. And again, then when it's done, it's then to be ready to be delivered to the client. So that's the steel done, coped, cut, painted even if he wants it painting. And then what the fabricator gets, he gets like a flat pack delivery of all the pieces ready to assemble together. And that's the last status then that the actual fabricator would do, is put them together to make the actual pieces, the final fabricated pieces. Now, there's some new technologies which have really just come to the forefront in the last few years. One of them is robotic welding. So this is typically still, most factories weld each piece manually, so they're all welded together. But there are new automatic robotic welding machines which can read the Tekla model and then actually take it down to the robots, and the robots will weld it as per the data in the Tekla model as well. So what we do in Tekla is we've got a new range of welding functionality that came out in version 19 and version 20, which allows us to put really any type of weld that you want within the model. This process reads those welds and then links down to the welding robotic machine. Okay, so let me take a quick look. Let's just open up another model. Let's go into the welding. Notice all named Riga. And if you take it into here, you'll see then here we've got a sort of assembly that's welded together. This is the example in the video. So you can see if I double click on these welds are a certain size, 6 millimeters, and they're a spacing of 200 millimeters. So we can say, let's make that 12, a little bit bigger, so you can see the actual change on screen. So now these welds are real objects, and it's those objects that the welding robots can read to actually do the welding on site. If I want to add something new, for example, I think I've got a plate here that's not welded. I can say, okay, let's weld. It then says, okay, what size weld do you want? Well, let's have a 4mm weld. And if we say apply and just create that, then what we do is that piece is welded to that piece, and it welds around that piece with 4mm weld. And it's that data that the welding robot will read. To download that, same kind of thing, one-click production. For me, as a detail, it's fantastic. So we'll go to the components. It's a plugin. If I come down here, then you see we've got a direct link. Oops, gone past it. There we are, it's the permit XML. You run on that. That actually then creates a link to the welding robot. Simple as that, one-click production, click on create, that's it. I don't have to worry about anything else. Oops, let me just pull that back up there. There we go. So again, once we've done that then, if we export the data, it then loads into the Perma software, which I don't have, I can't show you it live, but it loads into the Perma software and then directly down to the welding robotics themselves, which look like this. How that actually looks in real life, just go back here. Here we are, let me just turn the welding robots. This is what the actual process looks like in real life. For some reason, a bridge. Okay, this is part of our Tekla video, which shows people working on the same project at the same time. Of course, this is more about sort of engineering and that kind of thing, but what we're going to do then is we're passing that down to production. So taking those pieces, this is a simulation of what would happen, taking that down to production. Okay, so that's the piece, similar to what I just did then. You export it out just exactly as I showed you there. Then from that, it loads into the software that drives the welding robots. You can see the welds come through. You can alter those in the software if you wish. So if you want to make them bigger, smaller, take some out, or make everything 6mm, it's completely up to you. You get a small simulation of what the actual welding robot will do. You can check it's good. Then you can say, okay, let's do that for real. It downloads the welding robot. And this is, again, one guy driving the whole thing. So you can see that's the same piece I've just downloaded. And a nice welding robot which goes to it. My brother's a welder. I showed him this video. He was not impressed. So yeah, so all the welds there go straight down. So it's, we don't see too much of this in steel fabrication at the moment. It's mainly in shipbuilding, but it's coming more and more now into the steel fabrication business. So we are seeing a lot more interest in the sort of welding robotic integration. Okay, so again, take that down. It goes, you can alter the welds if you wish in the Perma software. This is the software that drives the machine, and of course then it starts the actual robotics. The machine itself with automatic turns, there's all different types of machines that are available, like so. Okay, so, just bear with me, let me just go back up here. For some reason I've got a few problems with the computer. So, bin forum, right. The next thing I want to take a look at actually is some other new technology. Well, actually, it's not so new. This has been out quite a while now, laser scanning, and how we can take those laser scan models into the sort of Tekla build and use them to work around. Does anyone use laser scanning options at the moment? Yeah. What it is, a laser scanner looks like this. It's a device. If you want to know how much they cost, they're about 40,000 euros. We don't sell them, by the way, that's the cost. So it's a station here. Pretty much what you do is I could put it in this room, put it down, and then it would scan the room with all you guys in it, and then what you get is you get a model, which then you can utilize, and it's like a one-to-one scale model. It takes about 10 minutes to scan this room. If you want to be really accurate, you can let it run for an hour. Let me just show you what these look like. Okay, so the laser scanner itself then looks like this. So let's say we want to work on this existing building. No coincidence that we are owned by Trimble, by the way. So this is the device. Quite simply, drop it into position. Don't know what that is. And then what it can do is it can scan that, sits there and scans the whole building. It's really interesting technology, actually. And for the steel business, we think it's an excellent fit for the steel, where we're doing retrofits and offshore platforms, that kind of thing. Okay, and once that's done then, it creates a model like this. I'm just going to pause that there. It creates a model. That's called a point cloud model. It's built up from a million little dots. So actually, it's not a real solid object, so it's very difficult for like softwares like Tekla to utilize that. So then what we have to do is we have to process that to build a DXF model from it, or DWG model for it. So you run it through a processing software, which then gives you a DXF we can use within Tekla. So although it looks solid, it's not. It's like a ghost. Again, a similar sort of auditorium to what we sat in here, actually. So the guy sets this up, and then again, just sort of scans the auditorium. These devices really are coming on strong, especially in retrofit, existing buildings, site surveys, where pretty much it will do all the sort of, one guy can do the whole layout without measuring anything. It's completely accurate as well. So again, you see this example here, and then again what you've got is you've got the point cloud model afterwards. Like so, and that's what you see on screen. Used existing buildings, offshore platforms where you want to rework them, anything that you wanted to rework or you need a sort of three-dimensional model of it. Like so. Okay, just minimize that down a moment. I can be able to show you this actually. Okay, I was actually going to show you the software, but I have trouble opening that up. So again, run it through, you laser scan it through. Then what we can do is we can process this. So you can then process it and it creates from that point cloud model, it creates actually a DXF, which then you can bring in as a real solid object into Tekla. A few kind of examples of that. Works quite nice actually, especially if you want to retrofit something. Again, there's an example of a church there that was done, point cloud. That then is scanned and brought into Tekla, which then we can kind of measure and work against. An example of where this was used, I've got to stop you, I've used this model now for the last 2 years, but we recently got involved in a sculpture that was done in the Netherlands. It was a piece of artwork. The starting point of this was the actual artist himself. What he did, he went and crouched down and he was laser scanned. Then the laser scan model was taken into Tekla for sort of work as well, and that was the final Tekla model that was done at the end. Again, just a small video of that. Okay, now hopefully if I just need to close down some of these PowerPoints actually.
Yeah? Maybe you can, let's say, come back to the sending information from Tekla to the different kind of machines. Could you just explain what type of machines maybe you can just have, or it's only those software you shows, or there are also possibility to?
Pretty much, there are a range of softwares that do production management. There's the one I showed here with steel projects, but there's one called FabTrol. There's Strumis. There's lots of different softwares around the world that you can buy, all with the same similar functionality, where we can take the Tekla model, pass them through that, and then create the same kind of data. Same as plate nesting softwares and bar nesting softwares. All these different softwares we can link down forwards to. Then if we come to CNC machines, all CNC machines, the major CNC machines, we have got direct links to them. We produce data, it goes straight down to the machines itself. A few of the advanced ones, we can then bring the data back. In that case, we're talking mainly Fee-Shep and Peddinghaus. That's which give the full BIM flow of bringing the information back into the Tekla model. Okay, so bear with me. One last little thing I'm going to just launch up. Well, we are part of Trimble, and Trimble own Google, so I'm quite safe to use this. Just looking at the laser scanning again, give an example of where that was used on a transmission tower. So here's a transmission tower model that was placed on terrain. So you can see that's actually a laser scan of the terrain that was placed upon, of the hillside. So that was laser scan. Then you can actually place the tower in its real location to get its real elevations and everything as well. And then from that, we can then, through SketchUp, we can place it in its real Google Earth location. So then from this, we can then say, okay, we are pylon, double click on that. Then it says, this one's in Arizona. So then we had the laser scan of the terrain, and then that's the transmission tower in its real. I'm really lousy at navigating this, by the way. So you can see then that's the transmission tower in its real. Let me just zoom in. I told you I was bad at this. So there's the transmission tower in its real Earth location, look like so. So a lot of the Earth is mapped in 3D. So when the Tekla model's completed, you can actually take that model and actually drop it into its real Earth location as well. And I just really wanted to finish on that last part, just showing you how you can sort of not just take a model down to the workshop, you can bring the data back and then actually put it in its real Earth location as well. So there we are.
As I mentioned, maybe we can just touch a little bit, at least tackle a possibility to work not only with heavy steel, let's say, but also with facades and...
Oh, facades, yeah, actually, yeah. Wasn't expecting this. Good job I'm prepared, isn't it? Okay, just bear with me. So we're just talking about facades, such as curtain walling, that kind of thing, so just bear with me. Just talk among yourselves while I find this. Okay, actually, no, let's have a look. So, and let's just ask for questions while I just find the model, please. In fact, I've got it here.
There are questions.
Let me just...
I know that in Latvia there are some fabricators which are using that way. One, it's from Elma Metal, one cut center in Riga. They belong to Elma group. They're working like that. And I know that there are some which partly working. We also have in Lithuania a few companies which also using partly this technology, just using Tekla models for sending the information directly to machines without any parts drawings. And of course they like it.
Okay, sorry, I didn't have this one sort of set up, so that's why I had a little delay there. This, what we've done a lot of work as well recently on sort of the facades and sort of curtain walling within Tekla as well. So although it's not typically part of our steelwork remit, we've had a lot of client requests saying, look, we want to put the curtain walling onto the structures now, what can you do? So we built a new sort of toolbox up with all the standard kind of profiles, the Schuko being the main ones. I don't know if anyone's involved in curtain wall, but Schuko are the main ones here. Then you get these really complex shapes, really sort of complex aluminium shapes. And these are the sort of aluminium shapes that go together to make the glazing or the curtain wall fixings. And you can see then we'll bring those into Tekla, give an idea of the section through of some of this stuff. So it doesn't matter how complex these sections are, we can easily bring them into Tekla and use them. So you can see again, you get the output from that, drawings, again showing how these curtain walls are put together, sectional view, and the sort of material list from that as well. And a couple of examples, just such as like a sort of example glazing top, the drawings for that. I've got a better example I'm going to move on to in a moment. And if I just skip through this, you can see then, just take a look at some of the examples here. These are Schuko panels which are built up from multiple layers of rubber gaskets, aluminium sections and glazing, and they're put together like so to create these panels. And that's what the panels will actually, the drawing it will create for us from Tekla. Now, I've got a nice example of a real one here, which was done recently in France. This is the new train station in France. All of this, it's a Tekla steel structure, but the curtain walling on top of this has also been done on Tekla, which is quite unique, actually. I'm not going to go through the whole thing, but you can see it's a very complicated three-dimensional structure. all glazing on top of that. You can see that's the actual Tekla model. This is some of the glazing panels and fixings that are there, and the sort of side panels and stuff like that. An example of that. So you can see again, just take a look at them. These are the glazing panels that we've built up. Sections through. Even with these profiles, we link them down to the machines to make the stuff as well. So ordering of the aluminium sections, the cutting of the length of the steel, it's all downloaded to the machines as well from our software. Again, one-click production. And that's what the panels actually look like on site. Like so. Just give you an idea how it looks. Quite nice, actually. It's still actually under completion, so I don't actually have the full complete model yet. But and again, another one that was done in France. Seems to be big on the curtain wall stuff. I do have the models if anyone wants to take a look in more detail. I do actually have the models, but I have to dig them out and find where they are. Okay, so that's my presentation finished. Thank you so much. If there's any questions, I'll take any questions, or if you want to speak to me privately, I'm available for the rest of the day. Okay, thank you.